Consider a projectile that is launched from the ground. It will travel up and then back down. When it reaches the ground here, its vertical displacement is 0 because it starts and ends at the same spot. It's launched with some initial velocity at this angle, and so it has components to its velocity. There's the x component, vi cosine theta, and there's the y component, vi sine theta. This y velocity is only what we have at the beginning. That y velocity changes as the flight continues, but the x velocity is constant the whole way. Imagine that I ask the question, how does the forward displacement depend upon the angle that it's launched at? Once we do the experiment and collect the data, it would be really cool if we could compare our data to theory. Do we know any theory, any equations that have delta x and theta? Can we derive an equation with those two variables? That would be pretty cool. Let's give it a shot. To find delta x, we would need to use this equation. Now, let's imagine it's too hard to measure the time that the object is in flight, which means we would have to calculate time from something else. Do we know any equations with the y-axis involving time? Well, many of our solutions utilize this equation. We've solved several problems using that equation. Inspect what you know. Delta y is 0, ag is negative 9.81, and viy is simply vi sine theta. Let's plug those values in and see if we can isolate t, the time. The initial y velocity is vi sine theta. Let's subtract this from both sides to move it to the left. When I subtract, I get negative 1/2 agt squared equals vi sine theta multiplied by time. Notice that I could divide both sides by t and cancel one of those t's. We're almost finished isolating t, which helps us, remember, plug back into this equation. So to isolate t, we have to get rid of these things. So I'll multiply both sides by negative 2. And that cancels out my negative 1/2. And finally, I'll divide both sides by the acceleration due to gravity, which we know is negative 9.81. Here's what the equation looks like. Remember why we found time? Because we wanted to plug it into this equation. After all, we're asking how far forward does the projectile travel at different angles of launch. So let's isolate delta x. Cross multiply. But we could plug in now for Vx, which is Vi cosine theta, and we could plug in for time, which is this expression, and this is what we get. This is a pretty complicated function. If we rewrite and rearrange, if you graph the displacement as a function of the angle, is it going to be a straight line like this? No, because this does not have the equation of a straight line, y equals mx plus b. That's not how delta x and theta are related. They do not follow a linear relationship. They follow this crazy complex relationship involving both a cosine and a sine. Therefore, the graph would not look linear like this. But check out this trick. What if instead we make a graph with displacement on the y-axis and the product of cosine theta multiplied by sine theta on the x-axis? Are those two things related by a linear relationship? Well, let me look at my equation. The y-axis is right there. The x-axis, this whole mess, is right there. And in fact, this does have the form of a straight line. What we have now, if we make this whole thing, if that whole thing is our x-axis quantity, then now we have y-axis equals slope multiplied by x-axis. And so this line with this crazy thing on the x-axis should be straight, and it should go through the origin because there is no y-intercept. That's pretty cool. To test this theory, let's use a projectile motion simulation from PhET. What we're going to do is click on Intro. We're going to click on this cannon or on this column and move down to create so that we launch from 0 meters like this. We're going to move our initial speed down to 10 meters per second, and we are going to click and drag the cannon up and down to change the launch angle. We can start at 85 degrees, and then we'll go by 5-degree increments all the way down to 25. So here's my Excel spreadsheet. I've set it up with the correct number of degrees, and then I'll measure the corresponding displacement. Notice how I have units in parentheses. Which of these is my independent variable? Which is my dependent variable? The independent is the one that you change in a very pre-selected way, so that would be the degrees. The dependent variable is also called the response variable. It adjusts based on the selected value of the angle or the independent variable. Okay, so to get started, first I'm going to use this button at the top to zoom in, and you can zoom out. And we're going to set the initial speed to 10. A pumpkin is perfectly fine. We hit this button in the bottom to launch, this red button, and it goes up and it comes down. There we are. What I can do is I can click and drag on this tape measure, and then I can position it. You see the crosshairs right there at the corner of the yellow tape measure. And then there's another crosshair over here. If I click the first crosshair, I move it around. If I click the second, I extend the tape measure and rotate. So I'm going to put this first crosshair at the same black crosshairs marking the beginning of the projectile's path. Then I'm going to move the second to the spot where the projectile landed, and I record that value, 1.78. I hit enter on my keyboard to move to the next cell in Excel. Now what I can do is I can click over here on my simulation. I can click the eraser. I can angle this down. I launch it again, and then I extend my tape measure. I record the new value, 3.43, and I keep going in this fashion until I've got all of my data, and I have all of these different values. So what's this next one? 5.08, and we keep going in this fashion. So here it is. I finished. This is my data. But now when you do your experiment, you will not use 10 meters per second. Instead, you will use 14 meters. Let's do 15 meters per second, so that your numbers come out different from what you see in this video. So use 15 meters per second. Your values should be different. Okay, let's start fresh with Excel. Find Excel, and one of the ways you can do that is you can click this icon in the corner, the Windows icon, and then you could type Excel and then choose Excel. You might also be able to find it on your desktop, but once you open Excel, you'll see a launch screen that looks like this. You can select, you can just select a blank workbook, and then you can expand it so it's on the whole screen. And what we will do is somewhere over here, maybe B3 or so, we can type out our independent variable, which is the angle in degrees. And then I can click or hit enter on my keyboard is the best, and it saves my work when you hit enter. Now, you see how this degrees text spills from B onto C? We need to widen this column. The way we do that is move your mouse so it's hovering over the B. And if you click, you could actually see, highlight the whole thing, but you don't have to. Just move your mouse so you're hovering over the B at the very top here, and then slide over to the right until you're right between the B and the C column headers. And when you get right between, you'll see this double arrow icon that's on my screen right now. The black line with arrows pointing in 2 directions. When you see that icon, double click. Double click the left clicker on your mouse and it automatically expands this column to fit the text. Let's do the same thing here. X displacement. Whoops. That's in meters. Whoa. And then I hit enter on my keyboard, and then I put my cursor above the C, I slide to the right, and I double click when I see that double arrowed icon. Double left click. Okay, now I have to type in my values. Now it would be wrong to do this because I'm putting letters along with the numbers. Excel requires numbers to be completely separated from letters. So let's do this. Let's type out just the numbers, the numerical values, no letters at all. Okay, so there we are, we're finished. If you know how to use formulas in Excel, and we'll learn that later, but if you already know how, you can simply do equals, click on the first cell, subtract 5, hit enter, and then you can drag that down to everything below to generate your degrees. Okay, now we type in our X displacements that we recorded earlier on our iPads. There we are. Now let's add a graph with our raw data. We need to select all of the numbers, so with your mouse, left click on the first value, just the number here, not the header, but just the 85. Left click there and then hold down so that you can drag across and highlight all of your values. Again, do not highlight the column headers. Don't highlight text, numbers only. Click the Insert tab at the top, and you might find that your Excel looks like this, so that when you click Insert, it falls down. That's okay, that's fine. You can change that by double-clicking Insert quickly, and then this ribbon will remain at the top. Once you select Insert, find the Charts section of the ribbon. We need a scatter plot, which is this icon where you've got the graphs, the axes, and then a bunch of dots in the middle. Click that scatter plot option and choose the very first selection, which has no connecting lines. Okay, we choose here, and there's our graph. Pretty cool. We can hit the plus, and if you don't see the plus, try moving your graph slightly. And if your graph is too far to the side, you can't see the plus. So I move it over. And then check the box for axis titles. Then I can click into this chart title and name it raw data. I can click once on this axis title, and then I click a second time to enter the text box. And then I delete everything that's there, and I call this, what's my y-axis? It's the dependent variable, x displacement in meters. Then I click on the x-axis title once, and then I click again with my mouse to enter the box. And then I delete that text and I put in its place angle in degrees. All right, we've got our first raw data graph. Now we need to make a second graph that has not angle on the x-axis, but what was it? If we multiply the cosine of the angle by the sine of the angle, then putting those values on the x-axis should make a straight line graph. So before we can multiply those values, we have to calculate the cosine of theta and the sine of theta. So we are going to have right here cosine of the angle, and then I click enter to save my work, and then right here we'll have sine of the angle. Whoops, sine. And we can again, between D and E, if you put your mouse above the D, not below it, not above, but just hover on the D, and then move to the right. And when you see that a double arrowed icon, you double click, double click. Okay, so we are going to calculate the cosine of 85, the cosine of 80, the cosine of 75, and put those values here. We'll do the same thing for sine. Now, if you wanted, you could get out your calculator and do all of this work, but that's going to take a really long time, and check out how easy it is to do those calculations with Excel. This is really cool. Before we do those calculations, let's convert the angle to radians, which is what Excel requires for cosine and sine. So right over here under C, I'm going to do angle, parentheses, radians, and then I hit enter on my keyboard. Now in this cell, we will type out a formula that converts the 85 into radians. We're going from degrees to radians. Every formula must start with the equal sign, so on your keyboard, click equals right now. It's beside backspace. And then instead of typing out 85, take your mouse, hover over the 85, and click that cell, which is B, column B, row 4. And look at what we've got here. This is called a cell reference, and Excel is replacing that reference with whatever number is located inside of cell B4. So okay, so right now that effectively is the degrees, 85 degrees. Next, to convert, we have to divide by 180, so hit the slash. That's right next to the shift button. The slash is the same as the question mark button. And then type 180 with the numbers on your keyboard. And we have to multiply by pi, so do star, which is shift 8 to get the star. And then type out 3.14159, and we'll stop there. Click enter on your keyboard, and there's our angle in radians. This would be a good time for a troubleshooting tip. Let's say you double click on your formula, and you start clicking away and you see something appearing, more cell references are showing up. How do you get out? How do you undo the work we're doing? Oh gosh, this is a mess. To undo and escape from the cell, simply hit escape on your keyboard. That's in the top left corner. When you click escape, it undoes your work. It doesn't save anything that you were just doing. So if I start typing and I hit escape, it undoes that recent typing. Okay, time to experience the magic of Excel. You might be inclined to click on the second line, click equals, choose your cell, and repeat the same thing. Do not do this. This is a waste of time. In fact, I can make Excel repeat the calculation with 80 degrees and 75 degrees and 70 degrees. I can repeat that calculation with just a couple of clicks of my mouse. Check this out. With your mouse, click on the cell with the 1.48, but you don't want to be inside of it, so if you enter the text by accident, simply click escape on your keyboard. All right, I've selected the cell, but I'm not editing the text. Move your mouse to the bottom right corner of that cell, and you'll see this black crosshairs icon. Once you see that black crosshairs icon, click with your left clicker and drag down 13 cells. Okay, let's see, including the top one. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Did I get it? And then once you've done 13, you release your left clicker and look at what we have. If I click on this second cell and then double click, it is performing the exact same calculation. It copied and pasted, but it's using 80 degrees instead of 85. Let me hit escape and then double click right here. This formula is using 75 degrees. This formula is using 70. When you copy down below to the cells below, the cell reference moves down too. That's why it's so great to click on the 85 and click it instead of actually typing out 85. Now you can see that I obviously went too far because I've got some zeros here, so let me highlight those. And then I'm not going to hit backspace because that doesn't really work. Instead, I'm going to hit the delete button, which is above my up arrow. Delete is a better way to delete things in Excel. Okay, let's do the same thing for these. Go to the cosine, the first value of cosine that we need, and click equals, type out COS, and then type, don't miss this part, type open parentheses, Shift 9. Click with your mouse on the 1.4835, and then close the parentheses, Shift 0. If you don't have the parentheses, it won't work. If you don't put the equals, it won't work. Make sure yours looks like mine. Then click Enter on your keyboard. Now we can click on the cell, highlight it, don't edit the text. If you edit the text by accident, click Escape. Select the cell, take your mouse, move it to the bottom right corner of that cell, and instead of clicking and dragging down, you can do that if you'd like, but check this out. Once you move your mouse to the bottom right corner, double click with your left clicker on the mouse, and it fills the whole row, the whole column automatically. Let's do the same thing here, equals sine, open parentheses, and then we click on the angle in radians and close your parentheses. Again, make sure you've got the equals, make sure you've got the parentheses. Then click Enter on your keyboard when yours looks like mine. I select the cell with my mouse, I move to the bottom right corner, I double click. Okay, now the final thing that we actually need on our x-axis is the product of the cosine multiplied by the sine. So let's go here and let's do this. Cosine space x for multiplied by sine, and then click Enter. And this will be our shorthand notation for we're multiplying this column by this column. Okay, go into the first cell here, click equals. Again, equals is right next to backspace on the keyboard. Move your mouse over so it's hovering above the first cosine value, the 0.08. Click with your left clicker on that value. Back on your keyboard now, hit the star, Shift 8. Then with your mouse, hover over the first sine value and left click. And then back to your keyboard, click on Enter. We are multiplying these two values together. Select that first product, that column, that is the first cell below cosine multiplied by sine. Move your mouse to the bottom right corner of that cell and double click with your left clicker on the mouse. The final thing is pretty easy. We are going to do this on the x and displacement on the y. That's going to be the y-axis. So to make life a little easier, let's click up here on these displacement values, and if you left click and hold down, you can, so I'm left clicking, and when I click with my left clicker, I'm holding at the same time. I'm dragging my mouse down, and then I am, with my keyboard, holding down the control button and then tapping C, and then I can let go of my control keyboard button. Click beside this cosine multiplied by sine. Click right here, and then hold Control with your keyboard and tap V to paste. And then I can let go of my control button. Again, if you hover your mouse over the G with a column header, and then you move your mouse to the right, once you see this icon, you can double click, and it will make this column bigger to fit the text. The final graph that we need is this on the X, this on the Y. So again, don't highlight the text, numbers only. With your mouse, click and hold on the first value and then drag your mouse so that you highlight all of those values. Go to the top to the ribbon, click Insert. In the Charts area, click the button where you have the scatter plot, which is just the axes and then a bunch of dots. Choose the first scatter plot option, the one with no connecting lines, and click with your mouse. Just like before, we want to click this plus, and remember, if your graph is too far over, you won't see it. And sometimes you won't see it anyway, so if you're not seeing the plus, try moving the graph around. You can also try zooming in or out. Sometimes that helps the plus show up. Click the plus, select axis title, and this time select trend line. I'm going to click away now. I'm going to change this to process data. Remember, you click once to select it, and you click a second time to enter the text box. I click once, and then I click a second time. Now this is still x displacement in meters. And this is cosine multiplied by sine. So I'll just label it that way. Now I'm going to double click on the line, the best fit line. Don't double click on a data point. Double click on the line itself. Make sure you've selected the 3 bars on the side and check the box for display equation on chart. Then click the X to close. If I zoom in on my graph, I can see it has the form y equals slope x minus b, or plus b. And it's a straight line, just like we predicted. This value is the slope. Now, we can predict what the slope should have been. 20.511. Hang on, let me go back and look at this. The slope that I've just acquired is 20.511. Your slope will be different. But remember what we said? We said slope is equal to this whole mess. 2 times the initial speed squared over the acceleration due to gravity. So here's what I'd like you to do. Plug in your initial velocity, which for me was 10, and solve for the acceleration due to gravity in your experiment. In other words, I'm going to actually solve this out. I'm going to do, for my initial velocity, I had 10. So I'm going to cross multiply by AG to get it out of the denominator. I'm going to divide both sides by 20.51. 2 times, well, that's easy for me, 100 over 20.511. Is this 9.81? I've typed it onto my calculator. I click enter. 9.75. Not too bad. My experimental value of the acceleration, whoa, I'm dreaming here. My experimental value for AG was 9.75. That's pretty cool. Now, technically, this should be a negative value, shouldn't it? The final 2 steps are to calculate the amount of error in our measurement, our value of AG, and then turn that error into a percentage. The error is just how far off you were. So it's the experimental value minus what you should have gotten, which was negative 9.81. And if I work this out, I'm going to get 0.06 meters per second squared. The error alone does have units. Make sure you include those in your answer. Then you take that error, and to turn it into a percentage, you divide by what you expected to get, what you should have gotten. And so we're expressing that error as some fraction of the true value. And when I do this, I get 0.006, and that's the decimal form. If you want to express that as a true percentage, you multiply by 100. So my percentage is 0.6%. So again, this is the decimal form is 0.006, which is approximately 0.6%. That is really incredible. Wow. So we're finished, and this is how we conduct the projectile motion lab. Thanks for watching.